Students, now we are going to solve the multiple choice questions in the chapter dual nature of light. The first question is the wavelength lambda e of an electron and lambda p of a photon of same energy E are related by. So these are the four options given. Which option is correct we are going to see. So what is given, my dear students? Both have the same energy. So the energy of a photon is equal to that of the electron. That is a clue given. So I start with energy of a photon. Okay. So energy of a photon is given by. So that is Max Planck's quantum theory of light gives what? E is equal to h nu. So this is also equal to what? hc by lambda. Since this is of a photon, EP for photon. So energy of the photon is represented by EP. The wavelength of the photon is represented by lambda p. So on the right hand side, h is Planck's constant, c is velocity of light, which is also a constant. Okay. Therefore, EP is proportional to 1 by lambda p. So this is the first expression. This is the first step. Have you understood up to this first of all? Okay. Now, when an electron of charge E and mass m is accelerated by potential difference of capital V volt, then the energy gained by the electron is half mv square is equal to charge of the electron E multiplied by the potential difference. Okay, from that we have already derived an expression for the de Broglie wavelength of an electron. Okay, my dear students, you tell me for an electron, the de Broglie wavelength is given by lambda. Okay, E is equal to h divided by square root of 2 into m into the energy. Do you remember that in the textbook it is given energy is taking what symbol? Capital K is given for kinetic energy. Here I am taking the symbol E because they have given the symbol E here. So the de Broglie wavelength of an electron is given by lambda E, that is equal to h divided by square root of 2m into E. So I will take the symbol E suffix small e for electron. So here also you see h is constant in the numerator. Similarly, in the denominator inside the square root 2 is constant, mass m is constant. Therefore, I can write, I can write like this, okay, or lambda E is proportional to 1 by square root of E of the electron. So, from this I can write R, okay, lambda square E is proportional to 1 by E suffix E. I have squared on both sides, so lambda square is proportional to 1 by energy of the electron. I am again rewriting this as what? R, energy of the electron is proportional to 1 by lambda E square. So this is the expression. Yes, students. So this is the expression number 2 for us. I am going to compare 1 and 2. So in the first expression, energy of a photon is proportional to 1 by lambda p. From the second expression, what? Energy of the electron is proportional to what? 1 by lambda square E. So it is given they have the same energy. No, they have given okay, same energy. Photon and electron have the same energy. So I will write since so EP is equal to EE, therefore the right hand sides must be proportional. So 1 by lambda P must be proportional to 1 by lambda E square, or lambda E square, okay, must be proportional to lambda P, or I will reverse this, lambda P is proportional to lambda E square. So this is the step number 3. Are we getting one of the options you see here? Which option is correct? Option D is given what? Lambda P is proportional to lambda E square. So which is the correct option? So option D is the correct answer. Have you understood? Okay, fine.